Hi, my name is Benedict Dungo and I'm going to do my laboratory exercise number 6, material planning. Material management is the planning and control of the function supporting and the complete cycle flow of materials and the associated flow of information. Their functions includes identification, uh, cataloging, standardization, need determination, scheduling, procurement, inspection, quality control, packaging, storage, inventory, distribution, and disposal. This is also called materials planning. There are two questions that we need to answer for this laboratory exercise. The first question is briefly, enumerate and briefly elaborate the problems with MRP system, or also known as material requirements planning. And number two is what are the solutions to data integrity issues and explain. Let's start with the first question. Enumerate and briefly elaborate the problems with MRP system. Problems with MRP systems. Integrity of data. If there are an errors in the inventory data, the bill of materials, commonly known as BOM data, or the master production schedule, then the output data will also incorrect. GIGO, or garbage in, garbage out. Data integrity is also affected by inaccurate cycle count adjustment, mistakes in receiving input and shipping output, scrap not reported, waste damage, box count errors, supplier containers count errors, production reporting errors, and system issues. Many of these type of errors can be minimized by implementing full system and using barcode scanning. Most vendors in this type of system recommended at least 99% data integrity for the system to give useful result. The next problem is system require that the user specify how long it will take a factory to make a product from its component part, assuming they are all available. Additionally, the system design also assumes that this lead time in manufacturing will be the same each time the item is made, without regarding the quantity being made or other items being made simultaneously in the factory. The next one is a manufacturer may have factories in different cities or even countries. It is not good for an MRP system to say that we do not need to order some material because we have plenty of it thousands of miles away. The overall ERP system needs to be able to organize inventory and needs by individual factory and intercommunicate the needs in order to enable each factory to redistribute components to serve the overall enterprise. This means that other systems in the enterprise need to work properly, both before implementing an ERP system and in the future. For example, systems like variety reduction and engineering, which make sure the product comes out first time without defect. This must be in place. The next problem is production may be in progress for some part whose design is changed with customer orders in the system for both the old design and the new one concurrently. The overall ERP system needs to have a system of coding parts such as that the MRP will correctly out calculate needs and tracking for both version. Parts must be booked into and out of store more regularly than the MRP calculations take place. Note, this other system can be be manual system, but must interface to the MRP. For example, a walk around stock intake done just prior to MRP calculation can be practical solution for a small inventory, especially if it's an open store. The last problem that with the MRP system is the other major drawback of MRP is that it fails to account for capacity in its calculation. This means it will give results that are impossible to implement due to manpower, machine, or supplier capacity contains. However, this is largely dealt with the MRP2. Generally, MRP2 refers to the system with integrated financials. An MR2 system can include finite or infinite capacity planning. Nevertheless, to be considered a true MRP2 system must also include financials. In the MRP2 or MRP2 concept, fluctuation in the forecast data are taken into account by including simulation of the master production schedule, thus creating a long-term control. A more general feature of MRP2 is its extension to purchasing, to marketing, and to finance. Integration of all functions of the company. ERP has been the next step. That's answer question number 1. Let's answer question number 2. What are the solution to data integrity issues? Please explain. Solution to data integrity issues. The first one is the bill of material or BOM. The best practice is to physically verify the bill of material either at the production site or by disassembling the product. The second solution is cycle count. Cycle count, the best practice is to determine why the cycle count that increases or decreases inventory has occurred. Find the root cause and correct the problem from occurring again. The third solution is scrap reporting. This can be the most difficult area to maintain with integrity. Start with isolating the scrap by providing scrap bin at the production site, then record the scrap from the bins on a daily basis. One benefit of reviewing the scrap on the site is that engineering group can take preventive action. The next one is receiving errors. Manual system of recording what has been received are error prone. The best practice is to implement the system of receiving by ASN from the supplier. The supplier sent an ASN, advanced shipping notice. When the components are received into the facility, the ASN is processed, and then company labels are created for each line item. The labels are affixed to each container and then scanned into the MRP system. Extra label reveal a shortage from the shipment, and too few label reveal overshipment. Some companies pay for ASN by reducing time in processing account payable. The next one is shipping errors. Container labels are printed from the shipper. The labels are affixed to the container in staging area or where they are loaded in the transport. The next solution is production reporting. The best practice is to use barcode scanning to enter production into inventory. A product that is rejected should be moved to the MRB or Material Review Board location. Containers that require sorting need to be received in reverse. The last solution is replenishment. The best replenishment practice is replacement using barcode scanning or by pull system. Depending on the complexity of the product, planner can actually order material using scanning with a min-max system. This concludes laboratory exercise number 6. Thank you.